Good morning, guys. This is the last chapter in statics, and in this chapter, we will learn how to find the centroid or the center of gravity, or how to locate the centroid, as well as how to find the moment of inertia. So, this chapter basically is divided into two parts. The first part is how to find or how to locate the centroid, and the second part is how to find the moment of inertia. In the first part, in how to locate the centroid, you should know, guys, that this is all related to the weight of this rigid body. I know basically, guys, that this rigid body is composed of a certain number of particles. Each of them has a weight of dw. Now, if I can relate the location of this centroid for the whole rigid body to the locations of these rigid particles or of these number of particles, I can find the centroid. I will start basically in this chapter by the proof. So we'll start by how to prove the equations of the location of centroid, and then I will solve some two problems on how to find the centroid for regular shape. Basically, guys, you should know that the first part of this chapter is applicable for regular and irregular shape. However, guys, we will stick to the regular shape in the problems, but I will prove how to find the centroid for any shape. Let's do it.
So guys, basically I know that a rigid body is composed of an infinite number of particles. Each of them has a weight of dw or d weight. And I need to find the location of the centroid or of the center of gravity for the whole body, for the whole rigid body. And I know basically, guys, that the resultant weight of this whole body will be located at a certain x, y, and z, let's say here. And this resultant weight will be, of course, equal, F resultant is equal to the sum of all dw. And I know that from math, the sum of dw means the integration of dw. So the resultant weight of the whole rigid body is equal to the integration of dw. And I need to know what is the location of this F resultant or of the resultant weight for this whole rigid body. Basically, guys, in order to do this, what I'm gonna do is to prove one equation on x, how to find the location in x, and then all other equations will be the same. I know, guys, that the moment of the resultant force around any point should be equal, guys, to the sum of moments of the forces that cause this resultant force. So what I'm gonna do now, I will find the moment around y. So let's find the moment around y. I know from the equation of the moments that the moment around y is equal to x times this force. So basically, guys, the moment of F resultant around y will be equal to F resultant times x bar that I need to find, and this will be the location of what? Of the center of gravity. Which is also equal to what? To the sum of moment of all these forces dw around y. And since here, guys, I have a differential w, then I will replace the sum by the integration. So it is the integration of dw times x of each dw. So each dw has a certain x, the distance between this dw and y, then the distance is here represented by x, by this symbol. Alright? Now, guys, I know that F resultant is equal to what? F resultant is equal to the integration of d omega. So I will take x bar here. F resultant is the integration of dw, and this will be equal to x dw. Now this bar here is the location of the centroid, is the x coordinate of the location of the centroid. And this one here, guys, is basically x, which is the location of each diameter. Now, what does this mean? This means that x bar will be equal to the integration of x. So I can now put x d omega over integration of d omega or dw. So this is the equation of x bar. Now, guys, I know that the weight is equal to the mass times gravity. And I know that the gravity is constant, so I can remove it from the integration. So if I replace dw here by dm times gravity, and then I take this gravity away from the integration, then what I will have is dm over dm, since I can simplify by the gravity. And here, guys, since this is called the center of gravity, now this is called the center of mass, and they have the same location. And now, guys, if I replace m by rho dv, and since this is a rigid body, then rho is also constant, or the density is also constant, so I can do the simplification, then this equation will be also equal to x dv over integration of dv. I can do the simplification with rho. And now, guys, if I am into d, then the thickness will be constant. The thickness in z, let's say, will be constant. And then this means, guys, that dv will be equal to this thickness times dA. And I can do the simplification of this thickness. And this means, guys, that my equation will be x dA over dA. And this is called the centroid. Basically, it is the center of area, and this is, guys, the equation that we will use in order to find our center. Now, guys, this integration could be replaced by the sum if I have some regular area. So I don't have to do the integration. I can replace this integration by the sum of x dA, or of x times a, over the sum of a. If I have some regular shapes, and this is, guys, our concern in this chapter, we will have some regular shape, and we have to find the location of the centroid. And of course, guys, by doing the same for y, you will find that y has also the same equation. Y of the centroid, or y bar, will be equal to the sum of y times a over the sum of all the regular area.